and welcome to Learning How to Learn Rust. I decided to talk about this from the point of view of an individual who is intimidated by this language that they keep hearing is too big to learn and is difficult. And I don't think that's necessarily true. My view is that you should start small and just start with a small part of the language and then grow that over time. This talk will be a demonstration of one strategy or for doing so. So that's basically the entire talk. If you're only here for two minutes, that is the main message. So just a very small introduction to me. I've been a programmer for about 15 years now. My academic credentials are in the humanities, though. I'm not a computer science major. As we've spoken about, I've just published the Rust in Action book. I'm also the organizer of our local meetup group, Rust Wellington. So there's a little bit of the cover. So about this talk, its aims are to provide you confidence. Its number one aim is to give you enough confidence to read the rest of the material. I can't teach you all of Rust today, unfortunately. And secondly, to provide you, though, with a strategy for learning, for some small core of Rust that can be used to make practical projects, and then you can expand that knowledge as you gain confidence. So the structure of the talk will be quite loose. We will be going through code examples, and then I will add some personal thoughts, and just a very small warning. Some of those thoughts will probably be incorrect and maybe even controversial. So we'll see what JT thinks of of some of the things that I had to say. Okay, so just my belief is that in terms of Rust, is that Rust is centered around two main things. One is this notion of a trait, and the other one is safe access to data. So if you can understand those two concepts, I think you'll understand the majority of Rust. And so I would focus on structs, vectors, or sort of like vectors of structs, iteration, so how to process that data within a vector, result, and option. Those types are how we express error or missing values inside of Rust programming. And if you can focus on that core of the language, my argument is that actually that will provide you the foundation to learn the rest. Everything else can wait. Okay, so let's learn Rust in small pieces. That means working with examples that provide immediate feedback. When you get the compiler to work, you get this kind of very small release of dopamine, and that's actually very positive from a learning point of view because it provides you with some encouragement to continue. And as you expand, as the compiler works for you and it compiles, you can then expand and move forward. So the first question is where do I start with Rust? And then we've got hello Linz. That's great. So we can print to the screen. That's probably the first thing that we do. And then we get this output, hello Linz. And then our next question is, well, how do I use a variable in Rust? And so we have our variable here, name or Name, if we're speaking German. And then we can expand our example. And now we've got some intuition about what a variable looks like in Rust. And then it's okay, so how do I create my own type? And that we create a struct definition with a name in there. And then we also learn about, as we go through, a syntax for defining a structure, where we have this kind of literal syntax within curly braces, and we put the name in here. And then we can field access. We use the dot operator to access a field, which relates to this string over here. And this all seems like it will work, and then sadly it will not. And so one of the very first things that you will encounter as a beginner Rust programmer is this distinction between a string and ampersand stir. Luckily, Rust actually provides a helper method, some help along with its compiler. It's well, why don't you try using toString? And right now, as a beginner Rust programmer, you don't need to know why that is important. But what I want you to remember is that even these very simple examples provide, like, there is actually quite a lot of complexity in going on here with types and with new syntax. And if you have not programmed before, if Rust is your first programming language, it's okay to go slow. We will actually describe, so we apply this method, and then we get the correct or the desired output. Now, the next question is, okay, so what is the difference between a string and an ampersand stir? So ampersand stir is actually normally pronounced as a string slice. And we will understand the reasons as we, or understand that distinction as we develop our understanding. But remember what I said about right now, we're just learning the core, and we will expand our knowledge over time. So the next thing that I want to know is, this syntax here seems kind of ugly. I would like to understand what constructors are. And so I kind of do some reading, and I discover this impl block, and I can add my own methods. Or in fact, in this case, it's a static method where I take an ampersand stir, and then I call to string inside new, and get the same result, which is hello Linz. And we're growing our language over time with small examples. And then the question is, okay, well, I'm doing some more research, and I want to understand how to accept either a string or a string slice. And so then I might encounter some example on a blog post with some syntax that's more ugly, or at least it's difficult. So the first thing to note is we have changed the type that our name is accepting from a specific type to a generic type. And we are asking Rust to provide, to accept any type T that can be represented as a stir, as a string slice. Actually, it's not capital S, like a little s, str, via an asref method, which sounds a bit strange at first. But what this means is that we can take a reference to our object name, and that will be represented as a string slice. And then because we know at this point here that we have a string slice methods do have a toString method, and which we've already used twice before. And so that can allow us to accept either argument. Now, if you are an experienced Rust programmer, you will know that this is like a very unsatisfactory this is an unsatisfactory way to get what to achieve the outcome that we want. We incur another allocation, a memory allocation here. And my argument will be that when you're learning, the extra 20 nanoseconds that you will incur via that memory allocation is an acceptable loss. Okay, and so we're continuing to expand our example, and what we want to now do is replace this print line statement here. Or I don't want to reveal the internals of name. I just want to be able to print a greeting. So how do I ask it to print itself? And it turns out that I've got, this is what we had before, and this here is new. So I can implement or bring in, I learn a little bit about bringing in other libraries, and I can implement a trait display or format display for a greeting, my custom type. And then all I need to do, and then I can copy the example that's in the documentation almost word for word and change some of the name variables and so forth. And then greeting is able to print itself. It's able to be accepted by the print, by this kind of special syntax within the print line macro. Okay, cool. We've gone through a little bit of the strategy of how to grow the language over time. you want to use small examples and grow them. So but I do want to give you permission to be confused because Rust can be confusing. For example, this is the implementation taken directly from the, well, it's actually, I've added some syntax, I've added some spacing because it's so small, for the standard memory drop method, function. Now, unlike our custom type before, so we'll start here, we'll start with the T. It accepts every type. Now, interestingly, we have an underscore or a prefix for our variable x, and that prefix of the underscore provides an indication to you. It's like a convention within the Rust community that we don't actually make use of that argument. And then it turns out, though, that to understand what this function is doing, you need to understand how Rust ownership system. And so what this syntax here does, we take the underscore x by value, and that puts that moves ownership of underscore t into the drop scope. And when drop scope when this scope ends, underscore t will be freed up or deleted. Now, if you don't know enough about Rust, it can be very, very confusing. And a good sign that you are learning Rust is being able to understand the drop function. Like if you have an intuitive understanding of what is happening here, that means it's very likely that you are learning Rust. Another one that confused me was the so-called entry API. So this is a hash map. So this might be a JavaScript object or a Python dictionary. I'm just introducing a little bit of some more syntax. So for every character in this string slice, so I can return an iterator of the string slice, character by character. I want to add in the character. So I've got this entry method in letters, and if either retrieve the count that already exists, otherwise start with 0. And then this syntax here with the star really confused me, because when I started with Rust, I had only used Python and I didn't really understand pointers. This counter is a mutable reference to what is inside the value inside this hash map. And so we can ask Rust with the dereference operator, which happens to be a star, that it should increment that number. And again, this is another case where if it probably looks intimidating and strange at first, but if you are learning it, if you find yourself understanding what is happening here, it's a good sign that you are learning Rust, and that's to be congratulated. And the other one, I think, is the other is another example from the standard library of something that I originally found very, very strange. Was all of this was the implementation of a conversion this conversion trait from. Oh, sorry. Actually, we're implementing into on the basis of from, and saying for every type t. So we're actually talking only about t, and we can convert it into type u. So for every type t, if u implements from of t, then t into u also works, and it's defined by its inverse. And so if you are becoming, this is another sign where it's okay to be confused at the start, and as your Rust knowledge grows, then syntax like this will start to be less unclear, at least, and hopefully over time actually understandable. Right. Okay. As you learn Rust, there will be parts of parts of your learning journey that will be difficult. And so my view is that you should try to be realistic with the amount of learning that the amount of new things that you can learn at any one time. It's okay to like walk your own path. It's okay to go slow. Um, Rust is different. Its ownership, it has a very helpful compiler, but its compiler is very strict and it's very pedantic. And so um, try to uh, try to make sure that you're kind of in the right mindset. One of the things that I think that you may wish to consider is like, why are you learning Rust? And we're in the situation now where Rust is very, very trendy. And I don't think that that motivation or being scared or worried about missing out is an effective way, or is likely to be an effective way for you to learn over time. And so potentially I would encourage you to switch that to like, what are some things that the Rust language can offer me that that other languages cannot? And the emphasis on safe access to memory is is very valuable, whichever language that you're using. Now, deliberate practice is the most effective way to learn, and that means that setting aside time and being deliberate is really important. Your local Rust community, Rust Linz, for example, for those in Austria, seems to be doing a fantastic job, and I recommend joining the Discord servers, either particularly smaller servers as well, or finding a group online that you can connect to and ask questions with. Smaller servers or smaller communities are often easier to ask sillier questions. And I personally recommend sharing things you learn as you learn them, because that actually, as well as teaching others, that actually helps you learn as well. Now, just kind of some more slightly philosophical parts. So I think that you should give yourself permission to fail. Learning Rust involves new concepts, new syntax, and new jargon. There's a lot that might be alien to your brain, and you need to give your time. You need to give your brain some time to learn, and it's okay even to be intimidated. The Rust community tends to attract people who are very skilled, and that has a negative effect to newcomers or to people who feel that they have less expertise. As it happens, almost everyone feels this experience, that everybody else in the room is more qualified than they are. And so as much as you can, try to forgive yourself if you encounter this kind of phenomenon inside your brain is lying to you. You are welcome here. The Rust community is your place too. You have a seat at the table, and yeah, your brain is lying to you. From a sort of slightly more technical note, I've already mentioned this very slightly. When you're starting especially, it's okay to use inefficient methods like clone and toString. If the borrow checker is, if the borrow checker is difficult, or you don't understand why the compiler is complaining to you, then it's okay to give yourself some more time to learn. And the other one, and this is like, I think, quite important, but if you're from C# or Java, it's very easy to write. People might laugh at you for writing Java or C# in Rust. And I want you to know that, I'm just going to get all of these through, that it's okay to write Java in Rust while you are learning Rust. There is plenty of time to learn idiomatic. So idiomatic Rust is very functional in its approach. It prefers higher order programming, and it prefers, I find, really, really elegant abstraction. And if you are the kind of person who likes to create an index variable I that starts at 0 and then increment that index over time, then start there, because I guarantee you that in 3 months' time that will change. But right now, what's important is your own learning journey. Don't learn more than the minimum required for the next step. Right. And one thing just very that I'd like to point out is that only a minority of Rust's programming community speaks English as a first language. And Rust uses terminology that's very confusing and you would not, for example, borrowing it doesn't relate very well to the concept of, say, borrowing someone's screwdriver or like hammer, because it turns out that you can have multiple borrows, like read-only access to data type, and that is something where there's a mismatch between the analogy and the Rust compiler. Likewise, ownership in Rust means something that's very different than ownership in terms of property rights. Property rights mean that you have the power to exclude everybody else from your property. But in Rust, ownership is related specifically to having the responsibility of destroying that value. When drop was implemented with just an empty block, drop had ownership of that value, and that's what indicated to the compiler that when drop scope finished, it should be freed up. Lifetimes are another sort of slightly strange concept. In our plain English, or the dictionary definition, does not stretch very far into a new programming language, and even things like references and smart pointers, all of this jargon can be confusing. And so, again, give yourself permission to go slow. There's plenty of time in the future. Okay. And likewise, when you are I'm actually going to speed through this little bit just because I just realized that I am sort of at 20 minutes now. But I would encourage you at some stage to practice reading at first more complicated examples. There are some very, very good Rust code around, and trying to develop an intuition for what's actually happening here. So in this case, we are connecting to a web server. We're creating an HTTP 1.0 request, and copying the output directly to standard out. And the other thing to note is that there's more than one way to achieve a particular outcome. In this case, we're looking for this octal value of 204, which happens to be 132 in decimal. And we could look through it by incrementing through the haystack, and then and we receive a reference to item here, and then if it matches our needle, then which is 132, well, then we print it out. Otherwise, we could do something slightly different, which is use the contains method. Either way is fine, especially while you are learning, because what's important is that you get the compiler to accept your code right now. And actually, I just want to say that even with a very small amount of Rust, you can do some things that are quite interesting. So we talked about structures and iterators. So we've got this. We've got a text. Well, we've got a string slice of New Zealand penguin data. So these are 3 species of penguin. The little penguin actually is, nests about 15 kilometers away from where I am now. And we take every line, we iterate through those records. And so this is a CSV. And just take a note of the things that you don't yet understand. So here's some new syntax. We've got a vector, and we are using an underscore as a placeholder, and we're splitting on commas. So that's these points here. So we now have we now have tuples, and then we trim all white space and then collect. A collect is doing something magical by taking all of our iterators and collecting them into one vector. One thing to note as well is this parse method. I used to find this very, very magical, but it turns out that we give a type hint to Rust, and it is actually able to inspect the string and say, okay, I know that you want a floating point number from, let's say, 65. I know what that means and I will try to apply the conversion, and if it fails, skip the record. If you build up from small examples and decide that if you build up from small examples, you'll be able to take on more and more complex programs quite quickly, I find. Okay, again, SmartFall, grow gradually. My view is that Rust is centered around traits and access to data. And so start with structs, vectors, and iteration. I also would also include result and option in there as well, and everything else can wait or will come next. And thank you very much for listening. I'm happy to answer any questions.